Okay, get out the factoring worksheet that we worked on Friday together. If you didn't get the factoring worksheet, if you weren't here on Friday, in the back of the room, there's a red notebook marked Algebra 2. The worksheets from Friday are back there, both this one and the one that we turned in for a grade. Okay, so this has all of our different types of factoring in it, and we did these two things. We factored with a GCF, and we factored a difference of two perfect squares. And I told you you need to learn your perfect squares. All right, so now we're going to move on to the next method of factoring. It is also a type of factoring that starts with two terms, so binomials. But this time it is a difference or a sum of perfect cubes. So I know some of you know your perfect squares, but I don't know if any of you know your perfect cubes. You don't necessarily have to memorize all of them, but there are a few you should know. 2 cubed is 8. 3 cubed is 27. 4 cubed is 64. You're going to see those show up a lot. Once they get much past that, they get really big. 5 cubed is 125, and 6 cubed is 216. So see how they're starting to get pretty big? So that's probably, if you have those memorized, you'll probably be doing real well. All right, so when you're factoring, you're going to do exactly what we talked about on Friday. First, always, 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 check to see if there is a GCF. If there's a GCF, you must handle that first. Get rid of your GCF or factor out your GCF. Remember, if you factor out the GCF, it may change the way you factor the rest of the problem. So you've got to do that first. After that, you're going to check to see, is it a binomial? Are there two terms? If they are they perfect squares? Is it a difference, that means subtraction, of two perfect squares? If it is, then you handle it by that particular pattern. If it's not, you move to the next question, which is it a difference or a sum of perfect cubes? Now this is different than squares because I can have a sum as well. But the pattern is pretty much the same. Much like with a difference of two perfect squares, you factor these in a pattern. So a difference of two squares had two sets of parentheses, 1 minus 1 plus. Two binomial sets of parentheses, two small sets of parentheses. This pattern has two sets of parentheses, but one is small for a binomial, and the other is large for a trinomial. So that's how you're going to factor these. That's your first step, is to put a set of small parentheses and a set of large parentheses. Now we want to ask ourselves, is there a GCF in this example? There is not. So we're going to move on to creating the factors. So you are going to create a small set of parentheses and a large set. That's always how you start this. One small set, one large set. Then, the sign that is in the original problem. So, this is my original problem. A cubed minus b cubed. I'm going to take the sign that's in my original problem and put that in the small set of parentheses. So, it gets a minus. Then, much like difference of squares, this time I'm taking a cube root, because these are cubes. The cube root of the first term goes in just the small set of parentheses. The cube root of the second term goes in just the small set of the parentheses. Now I am no longer dealing with the original problem. I've used everything from the original problem I need. Now I'm dealing with my small set of parentheses. You take the first term and you square it, put it in the first blank. Take the last term, negative b, and square it. Now when I square negative b, that's going to give me positive b squared. So remember, I said this is going to be a trinomial. To get that middle term, you multiply these two. That's going to be AB. Now the sign is going to come from the fact that you always have to have two pluses and minus in the final stages of this, and I've already used my minus. So this has to be a plus. Okay, I know that seems like it might be a little complicated, but I promise as we go through the pattern, you'll get used to it. The pattern for a sum of cubes is the same as the pattern for a difference of cubes. First you ask yourself, is there a GCF? This time there is. And I'm glad, because if there wasn't, these two numbers were not perfect cubes, nor were they perfect squares. But if I factor out a 2, that gives me 8m cubed plus p cubed. And now they are perfect cubes. All right? When I factor a difference of two perfect cubes, I have a small set of parentheses and a large set of parentheses. I'm going to go ahead and bring down the 2 because I've already factored it out. It is a factor in my final answer. Now I'm just going to follow the pattern. I take the sign from the original problem. It's positive. So my small set is going to be positive. Take the cube root of the first term and put it in the small set of parentheses. 2m is the cube root of 8m cubed. Take the cube root of the last term and put it in the last blank. Now I am done using my original. I don't need it anymore. I'm now getting everything from my small set of parentheses. Square your first term. Now don't forget, you have to square the coefficient. So it's going to be 4m squared. Square the last term. It goes at the end, plus p squared. And now the term in the middle comes from multiplying 2m times p. That would be 2mp. All of these problems have to have a 1 minus and 2 pluses. I have 2 pluses, but no minus yet, so that's going to be my minus. And that's it. That's your final answer. Just following the pattern. All right, so put this packet away, because we're not going to move till 3 terms until later. Keep this, because we'll do those at a later date. But now you should have this one. It gives you the pattern up here, so you can follow along the pattern if you need to. Let's just do a couple of these together. I'll do a couple of them, and then I'll give you a little time to do them before I put the answers up. All right, so first thing you ask yourself is there a GCF? No, there's not. It is a binomial, but it has addition. So I'm going to check to see if they are perfect cubes. 8 is a perfect cube. B cubed is a perfect cube. So that means I'm going to factor this with my pattern for cubes. A small set of parentheses and a large set. I'm going to look at the original problem and take the sign from it, put it in the small set. Take the square root, or the cube root, sorry, of the first term, put it in the first blank of the small set. Cube root of the second term, put it in the second blank of the small set. I am now done looking at this, and I'm using just my small set to fill in my trinomial. Take the square root of the first term, square the first term. That'll give me 4a squared. Don't forget, you must square the coefficient. Square the last term. That'll go in the last blank. And to get that middle term, you multiply the 2. So that's going to give me 2ab. Now remember, you have to have 2 pluses and a minus. So this one's got to be minus. Okay? Now this one looks very similar, but it's a difference. So still, let's go through all the steps just to make sure we don't forget. First, you ask yourself, is there a GCF? There is not. Is it a difference? It is. Are these perfect squares? No, they're not perfect squares, but they are perfect cubes. So I'm going to start my pattern with a small set of parentheses and a large set. The sign for the small set comes from the original problem. It's the exact same sign. Take the cube root of the first term and put it in the first blank of the small set. Cube root of the last term goes in the last blank. Square the first term. Square the last term. Now when you square negative b, it becomes positive b squared. To get that middle term, you multiply the 2. I have to have 2 pluses and a minus. I've already used my minus, so my plus has to be right here. All right. Try the next one. I'll give you a minute to try it yourself. Okay, first you ask yourself, is there a GCF? There is not. Is it a difference? It is not, it's a sum, but these are perfect cubes. So this is going to be a sum of 2 perfect cubes. So I'm going to follow my pattern, 1 small set of parentheses, 1 large set. The sign for the small set comes from the original problem, so it's going to be a plus this time. Take the cube root of the first number and put it in the first blank. The cube root of the second number, that would be 3b. Put it in the second blank. Now, I don't need the original anymore. To get my trinomial, I'm using the numbers from my new binomial. Square the first term. That would be 4a squared. Don't forget to square that coefficient. Square the last term. That would be plus 9b squared. Don't forget to square the coefficient. To get the middle term, you multiply 2a times 3b. That's going to be 6ab. Now my final problem has to have 2 pluses and a minus, and I have used my 2 pluses. So that minus goes in the middle. How'd you do? Alright, so moving on, trying this one. Alright, so the first thing I ask myself is there a GCF? No. Is there a difference? There is. Are these perfect squares? Now be careful here because 64 is a perfect square. So sometimes that'll throw you off. But it's a perfect cube also. And 27 is a perfect cube plus x has a cube and y has a cube. So that's your clue. This is a difference of perfect cubes. So I'm going to set up the pattern for cubes, a small set of parentheses and a larger set. The sign for my small set comes from the original problem. Take the cube root, so that would be 4x and 3y. Now I no longer need this. I'm going to use just my small set to create my trinomial. So it's going to be 16x squared at the front plus 9y squared at the back. And your middle term comes from multiplying these two, so 12xy in the middle. You need 2 pluses and a minus, so it's going to be a plus. Alright, one more for practice before you get a worksheet to work on. Alright, finally we do have one with a GCF. Remember, a GCF has to be evenly divisible into both pieces, and it's not just numbers, it's also letters. In this case, 3 goes evenly into both of these. So I'm going to factor out a 3, and this has 4 a's, this one has 1, so I can factor out at least 1a. That would leave me a cubed plus x cubed. Or 1x cubed, but you don't have to write the 1. Now, you're not finished though, because these are also perfect cubes. So this is a sum of perfect cubes. So I'm going to keep my 3a, because that's a factor. Use my pattern, a small set and a large set. My small set has the same sign as the original problem. Plus, take the cube root of the first, Cube root of the last. To fill in your trinomials, square the first piece. Square the last piece. Multiply the 2 for the center, and you've got to have 2 pluses and a minus, so it's got to be a minus sign there. Alright, so that is factoring the sum or difference of 2 cubes. So now you're going to get a worksheet that this is all you're doing, working on factoring sum and difference of cubes. Don't forget, you've got to check for GCF first.